All right, thanks so much, Hallie and the Carahsoft team for having us on. Really excited to speak to everyone today. For those who don't know me, though I do see a couple of familiar names on the webinar list, my name is Daniel Bardenstein. I'm the CEO and co-founder of Manifest Cyber. Though we're not going to talk too much about what Manifest does today, we are a software and AI supply chain security company, which in other words means that we help the critical organizations and government agencies around the world trust the software and AI that they build and buy. A little bit about my background, which has led me to both not just Manifest, but to some of the topics we'll talk about today. Started my career in Silicon Valley building enterprise security tooling for many years, including applying AI to cybersecurity data north of a decade ago. Switching from Silicon Valley on the West Coast to DC on the East Coast, where I spent 4.5 years within US government, including a 2 year stint at the Defense Digital Service, where I was one of the cybersecurity leads for Operation Warp Speed, which was the US's effort around all things COVID-19 vaccines and therapeutics. That was my first exposure to a global supply chain for the vaccines and understanding all the digital and software components that went through it. I also served as director of Hack the Pentagon before moving over to CISA, the US's cybersecurity and infrastructure security agency, where I was the inaugural chief of technology strategy, working on national level policy, security modernization, and internal tech modernization within the agency. So, all of those experiences, along with the work we do day in and day out with some of the people who are actually on this call, have gotten us deep into all things software supply chain. And specifically, what we're going to talk about is one of the more novel threats and risks in the software supply chain, which is foreign risk. It doesn't necessarily mean that anybody outside of your country or organization is necessarily nefarious, but in the same way that you trust your developers to write your code, it might be helpful and perhaps becoming increasingly critical to trust the developers of open source or third party components that go in the software that your organization buys and builds. So, first, let's talk a little bit about the problem, starting with what software supply chains look like and how they've evolved over time. So, when we think about what a software supply chain looks like, most organizations these days write software and have developers to author that software. We all know that developers, like anybody else, want to be efficient with their time. And so if they can leverage someone else's work, they're going to do it rather than writing it themselves. So for example, if you don't want to write another pie chart in Python, there's probably an open source package for you to use that lets you plug and play this pie chart functionality. That open source package is software and source code that someone else has written, right? Or some other people have written, and it may have inherited source code from another package and another package. And so you have this supply chain, this increasing, this step of increasing pathways and jumps from other people's source code that ultimately end up in your company's products and code. So when we're talking about a software supply chain, that's what we're thinking about, right? What is the code that's running in my environment that my company didn't write, whether because my developers brought it in or because it's in the third-party vendor technology that I've purchased, right? And these supply chains are incredibly opaque, right? We all think back to the Log4 shell vulnerability back in December of 21, where overnight there was a major vulnerability that put hundreds of thousands of agencies at trivial risk of being compromised. It took most organizations months at minimum to answer this very simple question of where is this library, log4j, running in my environment? Everything I have built and bought. That is a great illustrative example of how opaque software supply chains are. Most organizations don't know all the open source or third-party software that they're responsible for securing. What happens when the software supply chain is opaque? It becomes a great place for adversaries to attack. And here are a couple of examples of what this looks like. Again, this is not as much a hypothetical as it is a reality that is increasing. In 2024, we saw two pretty serious early and widespread examples of intentional supply chain attacks not just general, but from targeted foreign adversaries. XZUtils, common library used throughout the Linux server, and polyfill.io, a common JavaScript web package, were both intentionally compromised by actors affiliated with China, with the PRC. And backdoors were added to both to basically start stealing and harvesting credentials. So your application might just try to innocuously update to the latest version of these things to try to stay up to date on all of the open source packages. Inadvertently was bringing in compromised code that would steal credentials and send them to a remote server, right? Those were identified rapidly and mitigated. Most organizations didn't have a sense of how was I impacted. And then in this past 6 to 9 months, we've seen an amazing proliferation of this attack through Team PCP and other such adversaries that are intentionally using AI to compromise open source packages at scale. Why does this make sense for adversaries? Because it's cost effective. Rather than trying to hack into 1,000 different government agencies or defense companies, I can just put a backdoor into one package that everybody sucks in automatically, and now they've done the work for me. So the takeaway here for those who aren't familiar with all these things, everyone has software supply chains. For most organizations, they are incredibly opaque. Because they are opaque, adversaries like to target them, and that puts us all at risk. And this is something we need to illuminate. I led with this a little bit at the beginning of the call, but we have an expectation that we vet the developers and the employees in general that we have in our companies, especially the ones who write source code, since that is what many of our companies are based on, generates revenue, and can also, pose risk. I know that when we hire engineers at Manifest, we put them through a rigorous process, not just for how good of developers they are, but also we run background checks, we do profiling, etc. Um, if you vet your developers to make sure that they can be trustworthy and they're not going to run away with your source code or they don't have other affiliations, doesn't make sense that we should be assessing anyone who touches the source code that runs in our products, right? So those open source contributors that get it, those source code gets into our platforms again based on our open source packages that we pull in as we're writing code, or from the third party technology. If I'm buying a Cisco product, there's open source in there, right? Cisco doesn't write all the software that goes in their products. So how much do I trust all the software that I'm putting in my environment that Cisco has written or aggregated? And so there's a big blind spot, right? If source code is so sensitive and we treat it as intellectual property and confidential and trade secrets, we have a big gap in terms of how much we actually trust and vet people who are writing source code that are running in our critical systems and handling our sensitive data. So one of the key takeaways and one of the main problems is organizations within the United States government, as well as those who are selling into the US government, need to assess all the software contributors for the software that they're delivering or procuring. So this covers both the developers that are working within the agency itself or the defense company, or the ones in the supply chains. And even though we're all familiar with more traditional types of software risk, like vulnerabilities, right? There's some sort of exploitable vulnerability. Foreign risk is a major type of risk that most organizations are not yet thinking about or having operationalized. And this is what we're going to focus on today. That is a great precursor for trust, right? There may not be a vulnerability in source code yet, but if you're hiring developers you don't trust, or you're bringing in open source packages or third-party tech that you don't trust that may have foreign associations that could lead to various types of compromised or insider threat, that's something that security teams need to be aware of as early and as soon as possible. And so we have a poll, the first poll question coming up, I see. If everyone can take a quick second to answer that. And I'm just seeing up on my screen. I'll let that go. So this is, again, first key takeaway for everyone on the call who are either in government or selling to government. And we'll talk, or one of the key reasons why this is in the same way you vet your developers for their trusts, you have to be thinking about your software supply chains and your AI supply chains, and how do you assess trust and who their allegiances are to. So why does it matter for folks in the US government apparatus? First and foremostly, there is increasing regulation and official guidance from the US government around this specific thing. So I believe last year, perhaps it was 2 years ago already, the Secretary of Defense or Secretary of War put out a memo that effectively stated it is now the policy of the Department of Defense, Department of War, that they will no longer procure any software or hardware with ties to China or Russia or government affiliated or agencies within those countries. Again, without going into details, staying on the unclassified side, the US government has seen supply chain attacks where various adversaries will try to influence physical and software supply chains to compromise US government and national security systems. We have memos out of the White House. We have DoD's or DoD instructions for defense contractors. We have language in the NDAA and proposed legislation that would broaden this net so it's not just for national security systems, but anyone selling software, even for unclassified systems into the US government, has to prove that there is no risk of foreign influence in the software and hardware because this has been a risk and a threat that has already been widely seen, especially as people have likely read about in the last 6 to 9 months. North Korea has joined this game as well. North Korea specifically has been trying to place developers or fake, basically have their developers impersonate people in different countries in the world, applying for jobs and getting jobs working internally at major US and global companies, right? So one major blind spot is whether the developers you're hiring or the people in your supply chain may have nefarious ties. I'll talk a little bit about what that means to have a nefarious foreign influence. That again, organizations not just need to know about for their own internal risk, but to affect government business, government compliance, and government security. Another thing I should mention here as well, and I think I'll hit on this a little bit later, is this also applies to AI. So we often talk about software supply chains, or in government parlance, we talk about CSCRM or cybersecurity supply chain and risk management. This all applies to AI as well. AI is a subset of software. AI has supply chains. AI has open source or open weight components to it. And in the same way that you may have heard organizations or government agencies say, we're not going to use any Chinese affiliated AI, can't use DeepSeek, can't use Quen. How do you have a way of enforcing that, right? It's the same concept. How do you know who assembled the AI and the software that you're looking to use and integrate? So let's jump into some case studies on what this actually looks like. There are a lot of organizations that aren't doing anything now, and this is already causing them either risk or impact to the bottom line on revenue because of slowness to compliance or having to go back and do work. So again, this is not a hypothetical risk. There are costs that organizations are already facing because of this. So let's dive into some examples. There is an organization in the defense industrial base that we work with at Manifest that before we got into the depths of foreign risk in software supply chains, had told us that they had shipped the latest version of their software to their one of their customers in the intelligence community that has strict requirements around not having critical and national security software have ties to foreign actors or governments. And the customer flagged for them that one of their software components that they had put in the latest version had one of these ties and was manufactured by some developers in a foreign entity. That IC organization told this defense contractor that they had to go back and provide a new version without that component, with a substitute component made either by US developers or by developers in other trusted countries. It took this organization 6 months of work to correct this. Why? Because they had to figure out where it was being used. They did their own due diligence on who wrote it and what the level of trust is. Then they had to go find replacements that were, good alternatives that still work similarly in the same language that could be roughly swapped in. And then they had to reintegrate this new component and make sure it had all the right function calls and the right APIs and worked the same way that the original function did. And then obviously they have to do lots and lots of testing to make sure it all works. It's like doing a heart surgery. And then only after 6 months did they get to the point where the new software version was fully tested, validated, and ready for deployment. So that's half a year of time that this organization was forced to basically waste, put down the drain, because they didn't flag this earlier on during their design and development phase. And it's because of the requirements and the high bar of national security from US government agencies, and particularly the more sensitive ones. Another fascinating and interesting and perhaps scary story is we were working with another organization. This one was within the US Navy and a defense contractor that was developing a weapon system for the US Navy. We analyzed the unclassified portion software of this weapon system, and we found, we won't go through all the findings, but suffice to say, of the findings that we illuminated, there was a software component in this weapon system that didn't necessarily have an active vulnerability, but was 20 years old, hadn't been updated in 5 years, and was maintained by 3 people who all resided in Hungary. Does that mean that this component was necessarily malicious or tainted or a red flag? No, not necessarily. And, in security, there's already lots of fear, uncertainty, and doubt. And so we don't want to, cry wolf when there's not necessarily a threat. But you can imagine why this could be such a good vector for a supply chain attack. Neither the defense company nor the Navy customer even knew this library existed or that it was present in the weapon system. You could imagine, based on how a lot of software is developed, that just to stay up to date like we do on our phones and laptops, there might be automatic updates. So, hey, if there's a new version of this library, it's not pinned, or if when I bring it out, it is no known vulnerabilities, I'm just automatically going to bring in the new version, especially if it's 5 years old, right? Like there might be some good bug fixes or security patches there. They would be completely blind to any backdoors or supply chain attacks or implants that were put in that library. And if that came out 6 months later, they would have had no idea if they were even affected. So again, one of the take homes here, or there are several. First is, again, another great example of how opaque software supply chains are, especially for large scale systems. We think about the US government, it's not just about your web apps, but there's certainly true of web apps. It applies to weapon systems, it applies to planes, to cars, to logistics management systems. All these things have increasingly complex software supply chains, and sometimes the organization that assembles this technology doesn't even know that these things are there. And the second key takeaway here is, again, we often think in terms of vulnerabilities. We have, between NIST and RMF and all the other frameworks and regulations we have around the U.S. government, everything really focuses on vulnerabilities. But we also just have to think about inventory and awareness and foreign risk, because that is a different sort of risk that might impact us months down the line. And I doubt that this is the only place in the US government where this types of threat exists, but it's an illustrative one. So let's talk a little bit about how we got to this point societally and why things are the way they are. And then we'll get into what we can actually do about them. So self-reported location is not verification. What do we mean by that? There are people, organizations, even vendor products out there that say, we can tell you foreign risk in your open source supply chain. I can think of a couple cybersecurity vendors who claim this. What a lot of these companies do, and what even a lot of contractors or consultants do, will just look at where people say they live, right? So I look at an open source package on GitHub, I click through some of the top contributors, and they say, hey, I live in Beijing, China, or I live in Sao Paulo, Brazil, or I live in Budapest. But what most people don't realize, or perhaps we forget, is that that is self-reported location data. And we can't necessarily trust it. I could go on to GitHub and say that I'm calling you from South Africa right now, when I'm really in the United States. No one's validating or verifying that. GitHub is not an official place for identity verification. In fact, it's quite the opposite. So when companies out there are talking about being able to assess foreign risk in software supply chains, or we can understand where someone is located. Location is not sufficient. Also, the reality is a lot of open source software is written by people around the world, in Russia, in China. There are a lot of developers there. Not all of them are necessarily nefarious. Not all of them write malicious code. They may be extra subject to their government will and could be pressured, but it'd be wrong to flag any piece of software all the time written by anybody outside of whichever country you're in. So really what we need to understand when we're assessing trust in a user is what are their affiliations, their associations? Is there any reason or motivation that they would be non-trusted or put a sort of backdoor or malicious code into software that my organization might be sucking in? Here on your screen, you'll probably see a second poll about foreign risk specifically. If you can take a couple of seconds to answer that, I'll read it out since why not. What is your organization's biggest challenge when assessing foreign risk in your software and AI supply chains? Take a minute or so to look through the options and fill one out. All right. So we talked about affiliations and not just addresses. So what is an example here? It would be helpful to understand whether a developer of some sort of open source component was, for example, former security services or intelligence services for a Russian entity like the GRU or from the PRC, right? So not just the everyday citizen, but somebody who came from that surveillance world or that security world. In the US, we maintain sanctions lists, both of countries and of organizations and developers or just individuals. And so knowing that a user works for a company that is on a sanctions list is really important when we think about compliance and national security risk for the US government and our NatSec apparatus. So it's really, really helpful to understand, again, affiliations, not just where people live, understanding if they're part of like the Chinese talent programs, if they have affiliations with defense universities or other defense institutions. There are many different types, and not one set of affiliations is necessarily a red flag, right? This is something that every organization writing software or buying software will need to assess. What sort of affiliations do we care about in our software supply chain and AI supply chain? Which ones are more likely to be a risk for us? And so it is critically important that, again, we don't just stop to check the box of, oh, I have, and I'll give an anecdote here, right? When we at Manifest we're recently going through some paperwork for a DOW innovation contract, like a SIB or a SITR. We had to fill out some paperwork around who the leadership of the company was and the major investors of that company, and we had to provide the location and the citizenship of all those people, right? So this is a step in that direction, but it doesn't necessarily mean that, and shouldn't necessarily mean that a company or a product is bad because they have an investor who lives in China or in Hungary or wherever else, right? People live different places for different reasons. They may have citizenship. It doesn't necessarily mean they're malicious or insider threat. What would be more helpful during that process is looking at who has access to the software, who can actually affect the software in a way that could affect the data that gets put into the software or the network on which the product is deployed, right? And how do we know that the people who are touching that software are trustworthy and have aligned interests and don't have affiliations with potentially problematic or risky institutions? Sorry, slides are going a little bit wonky. So now let's talk about what we can actually do about this. We've talked about the problem, the nature of the opacity of software supply chains. We've talked about some case studies of what this looks like. We've talked a little bit about how we've got here and why, just understanding where someone lives isn't sufficient. We need to know where they worked, who they work for, other sorts of affiliations. And that doesn't necessarily mean that anyone who works for an external company or a foreign government is nefarious, but it gives us information and data that we can take action on. We can decide on our compliance or security or legal review whether it is acceptable for us, right? So we need to have information in order to make decisions. And so the quality of the data matters a lot. So before we start on how to operationalize FOCI, again, stands for foreign ownership and controlling interest, there's a third poll question that is appearing on screen about maturity of the processes that you all are experiencing. How does your organization currently respond when a new vulnerability or foreign risk exposure is disclosed? A great example for those who are responsible for cybersecurity, maybe were around when exutils or polyfill.io happened. They're not traditional vulnerabilities that would show up in NVD or other vulnerability databases because they're not vulnerabilities. They were intentional takeovers and backdoors by nation state adversaries. So please fill in your information. All right, let's go into how to operationalize this, how to put it into practice. So I've already alluded to a bit of this, but let's dive in specifically. Every organization should have, every company or government agency who's looking to reduce foreign risk in their supply chain needs to agree on and have established policies for what are the affiliations that move the needle, which are the highest proxy flags that suggest that there's some sort of risk that someone needs to review, whether it's further research or compliance or legal, or just, hey, we're not going to take the risk on this thing, we're going to look for something else, right? So based on some of our research and with the data we have at Manifest and with the work we do with organizations in the defense industrial base and across the US government, the highest signal affiliations we have seen and heard ties to foreign government intelligence and military agencies. So people who currently are employed by or formerly were employed by specific government security, intelligence, or military services is a really important flag. Another one is people who work for entities on various sanction lists, which that usually is a precluding obstacle to even sell the product into USG in the first place. There are banned countries, like we talked about, China and Russia, Iran, North Korea are the low-hanging fruit, but there are other ones that are added that are often will get flagged. I think Syria is on that list, Cuba as well, so making sure there aren't any software or ad components that had hands on them there. And even just not knowing anything about a particular open source contributor, right? If you identify an open source package in the software that you build or buy, and it's maintained by one mysterious person with a weird handle that doesn't have an internet footprint, and they live somewhere random in the world, it just may be too much of a business risk to not have that information about who this person is if they control a critical part or even a small part, but get access to your software supply chain. It may be worth going with software created by a larger and more reputable institution. Then, as we know in open source, there are a lot of libraries that are just maintained by one or two people somewhere around the world. So even the lack of information is important information to help make decisions. And again, why is all this important if we zoom out? One of the best ways to reduce risk and to reduce cost is to prevent this up front, right? As we're writing code and as we're buying software. We think back to that example with the defense company that took 6 months to rip out a foreign component and then replace it and retest and revalidate and then redeploy it. How do you avoid that? By, in security we say shifting left a lot or moving things earlier into the design process. That's ultimately where this becomes super valuable, right? Because the affiliations are there. It's not necessarily they're going to pop up randomly 9 months down the line. So it's making this decision when software is being brought into the ecosystem. So let's deep dive a little bit on those specifics and what this looks like. So the first area is code that your agency writes. So these days, almost every government agency and almost every defense contractor writes software. And there are already existing processes for how security is applied in that software development process, right? So you have developers, they write code, or these days they tell AI to write their code for them. Is a good example, right? The AI will just grab random dependencies, random open source packages off the open internet that it thinks make it easier to get the job done. AI doesn't really look at how much do I trust these open source packages, or when were they last updated, or do they have vulnerabilities. kind of grabs it off the internet. Then once the developer writes the new feature and does some light testing, they'll open a pull request, they'll push it through their pipeline, and then, mature organizations have a set of automatic scanning steps that scan the source code and scan the dependencies and scan for other sorts of risks. They flag risks and then they send them back to the developer or to the application security team to fix, right? Like a vulnerability. It says, hey, we're going to block this code because there's an exploitable vulnerability and the developer has to go fix the issue and repush. So most agencies already have this, and we already have the process for it, which is great. So what is the net new thing to add onto this process? To add foreign risk scanning into the process of new code brought in, right? So when a developer writes code or tells Claude Code or OpenAI to write code for them, and that those tools just go in and grab a bunch of libraries, whatever they can find, and then the automatic scanning process kicks off. Yes, there should be a process that scans for vulnerabilities. Yes, there should be a process that scans for things like license issues. Make sure that your source code is appropriately licensed. But you need to have a scan for foreign risk contributors in that supply chain. So Claude Code grabbed a random pie chart library. Who wrote this library? What do we know about them? Where do they live? What are their associations? Have they been affiliated with other attacks in the past? And if they don't meet your policies, you block that code from getting into production, just like you would block that code if there was a critical vulnerability in it, right? So the best, easiest, lowest cost way to do all of this is to stop it at the source and to keep things light on the developer, which means doing it automatically in the CI/CD pipeline or the software development lifecycle, the SDLC. And again, the more you can even automate this with your AI coding tools, right? So if you have your ChatGPT or Codex or Claude Code or Copilot, building in, tooling integrations into those tools so they don't even go grab problematic libraries in the first place. That's the easiest way to build and ship fast without burdening your developers and without bringing in untrusted, risky software. This is big, especially as we see Fortune 500 companies and defense companies all rolling out AI very, very rapidly, and everybody has this hope of AI. I'm just going to write a guidance file to the AI that says, oh, don't bring in any problematic components and don't write vulnerable software. It's not how AI works. We've seen it time and time again. It will write vulnerable software. It will bring in questionable dependencies because it just doesn't have that data. You need to have additional tooling and data sets to plug into what you currently have to flag this risk. So that's everything about when you write code, when your agency is writing new software. What about the other source, when you buy third-party technology, right? So in the same way that your developers almost certainly are using open source libraries, so are your vendors, right? I'm not just poking at Cisco, but it's everyone. Cisco, Microsoft, Google, F5, anyone, and we all know the vendors that are widely used across the US government, they all put an open source into their products too. And that means that they are bundling potentially risky software into their software and then selling it to you. And now it's your job, your agency's job, to defend it and secure it, right? So how do we apply this to CSCRM or third-party risk management or procurement? A, have strong policies for what is acceptable. In the same way that the DoD has put out this guidance that says there cannot be software or hardware with ties to these countries or these groups, you should do that for your organization, right? Make that very clear. Second, make sure you can actually back it up and hold your vendors accountable, right? One of the best ways to do that is to get information from your vendor in the form, ideally, of a machine-readable artifact, like a software bill of materials, an SBOM. For those who aren't familiar with the SBOM, it is a list of all the software components that make up a piece of software. So it's not the source code from your vendor, but it's going to be all those open source or third-party packages that then your agency can scan and understand foreign risk before you even deploy or procure that piece of technology, right? And ideally, you want to automate this as much as possible so you don't have stuff flying back and forth over email. But this is a really tried and true way for and there are agencies and defense companies who already do this, who have strict SBOM mandates for all of their suppliers, because this gives them a way to scan for vulnerabilities, license risks, foreign risks, other sorts of risks in their software supply chains, knowing that they're not going to get their supplier's source code, right? And one of the best ways to reduce risk, like I said, is to keep it from coming into the organization in the first place. And we've seen this happen multiple times. You'd think it would maybe slow down procurement or affect the bottom line. But when suppliers really want to win the contract, especially with the U.S. government's very large contracts, if the procurement official or the AO says, we found these three risks in your software, and we're not going to go forward with procurement until you give us a new version without these risks, those suppliers, those defense companies will do that and will do it quickly. And we've seen this time and time again. And when they make their software more secure, they make every other government agency and defense company more secure that buys that technology. So there's a great network effect here of we're actually making the ecosystem more secure by having a higher bar for the security and the trust of our third-party tech. And FOCI, foreign risk, is a huge part of that as well, because you don't know how Cisco or F5 or CrowdStrike writes their software as well. They might have offshore developers somewhere. They may have accidentally hired North Korean operatives. That still happens a lot. And now you're taking the risk and you're holding the bag for it. Another way to operationalize this on the AI side is to think about what AI models, and again, this can be applied to open source packages and software that you use. But let's focus in a little bit on AI because most of the conversation, both today and in general, focuses on software and open source, and people don't think as much about AI. I was just talking just the other day with the CISO of a large government agency who was knowing and pushing and advocating that their agency at some point is going to need to bring models in-house, not just use OpenAI or Anthropic's Claude models or Gemini where data goes outside of the system. They're going to start using their own internal models and tuning them and using them in their secure enclaves so they can do their job without trusting on a third-party vendor and losing their data, but also so they could fine-tune the models to be very precise and very accurate. This is a great place to, again, keep that bar high and assess risk before you bring in tech into the environment. And I know there's some people on this call whose responsibility it is to do this for their agency. So what this looks like, for those who are familiar, is there are lots of different AI assets out there on the open internet, lots of open weight models, lots of publicly available data sets, right? And like I said at the very beginning of the call, developers, like everybody else, want to hopefully reuse someone else's work rather than build it themselves. And so as we're all racing to adopt AI, there's going to be people in your agency, in your business, who are going to want to find a model that's already exists so they can bring it in and move fast. And this thing is really good for a defense use case or a military use case or summarizing emails, etc. These models and data sets have risks too, and not just traditional security risks like bad licensing, like vulnerabilities, but they also have foreign risk as well. So the most obvious one is DeepSeek. For those of us who are familiar with, AI models, when DeepSeek was first announced, it caused this really big splash because it was cheaper and just as effective and just as fast as a lot of the US models, but it was developed in China and it was realized that a lot of the data in the DeepSeek app was going right back into China. And so the government, a lot of defense companies had a strict no DeepSeek policy or a broader no Chinese AI or Chinese models policy. Sort of easy to implement, right? You just want to make sure that no one's using DeepSeek and maybe you block the URL. But how do you know if there are other models that people are bringing in that might be derived from DeepSeek? And we've heard some anecdotes from very large companies where, let's say, somebody in a business unit or a particular component in a government agency really wants to use this model out there because it's cheap and it's fast and it's accurate, but maybe it's based on a Chinese model or it is a Chinese model. And we're seeing this actually a lot in startup land right now because the Chinese models are faster and lighter weight and a lot cheaper. And so a lot of startups, especially in the US, are starting to use Chinese models to get off the ground because Anthropics and OpenAIs are so expensive. So those developers can take those models and tweak them every so often to pretend like they're in a different model, right? So I start with DeepSeek or Qwen, and then I make a slight modification. I try to pretend like, oh, it's Daniel's model, and my compliance team won't know about it, right? This is something that becomes another blind spot, right? Now, you don't know that you're taking in Chinese AI because one of your developers, intentionally or unintentionally, tried to mask its associations, right? So as we think about AI, not just software, right? But AI, the models that we're using, the data sets that they were trained on, there is an element of trust that we need to assess in who wrote this model or assembled this data set. Where are they from? What are their motivations? And do we trust them? Is it an individual somewhere in Kansas? Is it a company in Malaysia? All those things tie into how much we trust this model or this data set that we're going to use, bring in, and deploy in our technology. So a really, really big emphasis here. When we think about C-SCRM, we think about software supply chain. This also extends to AI, right? AI can have different supply chains than the software it's built in, and it's critical to understand who are the people and organizations and affiliations that put together this AI, because we've already seen AI supply chain attacks where I might try to hide something in the data set that says, hey, for the self-driving car that I know this US company likes to use, I'm going to poison the data so it's going to accelerate every time it sees a stop sign and wreak some havoc, right? We need to understand and assess trust in who makes the AI and the software that we build and buy. So that largely concludes the main content that I had for the webinar today. I wanted to open up the floor to some Q&A that we have before we have a couple of last next step and closeout slides.
Perfect. So we have a quick question from Ryan saying, for the stale Hungarian dependency, seems like glib that the system owner could fork and bring in-house. Have you witnessed that happen or be discussed?
It's a great question. So if you fork an open source repository, you're preventing issues from then a point in time forward, but you still need to make sure that you trust all the existing source code that's there. So yes, theoretically that is an option. Um, but again, your organization has to decide whether do you want to fork and just completely reassess and resecure and reharden that library, and then that means your organization is now on the hook for all the security of that open source forked package. So let's run through this scenario. Let's say there's uh, yeah, let's call it glibc, right? And then you fork it, and then you have your own Ryan version of it. If 6 months from now the original glibc project says, "Oh crap, we found a vulnerability," somewhere in our system, you now need to be aware that it affects what you built, even though it's not linked to glibc and where is it and who owns it and who has that information. So yes, it's possible, but it creates a greater administrative and operational burden when you are inheriting risk and now dissociating that kind of automatic connection. So is that a possibility? Yes, but it comes with costs. So a lot of, and we see it more frequently that organizations will look to switch altogether to a different component that they trust and they trust the supply chain of, rather than fork it and take on responsibility for maintaining it themselves. That's part of the benefit of using open source is there's shared accountability for updating and maintaining and securing that software rather than owning it all yourself. But it's a very good question.
Perfect. And then we have another question. So, Daniel, we're seeing a lot of agencies say that they have SMOBs on file, but still feel blind on their actual risk. What's that gap?
S-bombs, yes. We hear a lot of their government agencies and even a lot of defense companies that get S-bombs from their vendors, but don't feel like they've closed the gaps. And the conversation that we end up having with them is an S-bomb at the end of the day is just, it's a file. It's a piece of data. And if you put it in a SharePoint folder or a Teams folder or it's stuck in someone's email, it's not going to make much of a difference for you, right? The value of the data is in what you do with it. So having S-bombs is a good start. It's better than not having S-bombs. But if you're not scanning them, if you're not enriching them, if you're not validating them, if you're not doing continuous monitoring on them, they provide you very limited value. So we continue to work and see everyone from government agencies to defense companies, even to Wall Street banks that we at Manifest are talking to and supporting and working with and saying, hey, A, we don't have S-bombs from our vendors. How do we get them? And then how do we turn them into actionable data? But we also talk with people who say, hey, I actually have S-bombs. There's that group within the Air Force we're talking with it that has a problem. Hey, we have S-bombs. We're not doing anything with them, and they're not actually providing any value. So just like any other piece of data, the security you get out of it is all about what you do with it. So having the data is a good first start, but if you're not actively doing something with that data, and in the case with SBOMs, enriching, validating, scanning, continuous monitoring, taking automated action, you're not really going to see the return on investment or that reduction in security risk as a result. Also, good question.
Perfect. And we have another one that says, how does FOCI apply to AI?
Yeah, so we hit on that a little bit. Again, these days there's the baseline of if you're a defense company or a US government agency that just has a very simple, like, we're not using any Chinese AI, then you need to be able to assess who are all the people who've touched this model or this data set. Where, I see a lot of data sets that are out there, and even if you look on Hugging Face, where a lot of models are hosted, if you look at the data sets used to train the models and you chase that supply chain on where did this data set come from and who assembled them, there are a lot of data sets that were assembled by Chinese universities or security researchers within China. And again, it's not to say that that means that it's nefarious or malicious, but it may be non-compliant for your policies, and it may be a source of risk, and it may be something that your compliance or legal team needs to review before you decide whether or not to use this. So it's not just about who literally wrote the code of the model, but it's about who did that person work for, who owns the security and maintainability of that model, but even all the way down to the data sets, who put together the data set, and the same thing, who are their affiliations with? Because again, as AI continues to proliferate, and we talked about how adversaries love to attack opaque supply chains, AI has very opaque supply chains, and we expect and continue to see nation state adversaries are continuing to target AI supply chains exactly for that reason.
Perfect. And we have one last question. It's a bit long. So it says, how do foreign adversaries actually exploit software and AI supply chain weaknesses? Is that primarily a procurement problem, an operational problem, or both? What should agencies be looking for that they're probably missing today?
Yeah, so let's talk about, we just talked about a little bit about the how, right? So on the software side, foreign adversaries are going to look to basically add backdoors, right? How can they add in a little bit of code that makes the tool, you can think of it like maybe like a remote shut off, right? Hey, when an adversary wants, they're going to make something that will disrupt the software running, or it may steal credentials. That's another common one. So that's common on the software side. They're going to try to steal your data or disrupt the technology that's running. On the AI side, we see a lot of model poisoning or disruptions to the prompt. So you could imagine that the system prompt. So there is a world where, you know, let's make it a little bit hypothetical. Let's see there's a Chinese-made drone like DJI, and the navigation and like identifying who's a good guy versus who's a bad guy, it works great unless it's being pointed at a Chinese target, in which case it says all the Chinese targets are good and not bad. That would be an example of a hypothetical but plausible supply chain attack on AI, especially in defense systems, and why that's problematic. Who owns the problem between procurement and application security? To be honest, it's a bit of a joint venture, and the agencies we've seen that do this the best have tight collaboration between those two teams, right? Procurement C-script teams, they're not always as technical as your application security or product security teams, but they're the ones who are governing that procurement process and that validation verification process. So in the agencies that I've worked with that do this well, when new tech comes in, not only does procurement have a really high bar for the security and the risk of that software, but they'll bring in their hardcore security practitioners to say, here's the SBOM or here's the binary we got from this vendor. Help me understand what the risks are in an automated way so I can communicate it back to them. And then making sure that the application security team handles that first party, like what's getting written, right? So procurement owns what's coming in from the vendor side. AppSec owns what's being written inside the agency, but they should be in close collaboration, especially on joint set of policies and tools and automation.
I will share my screen.
All right, and that so I got one or two more. Sorry. Just
Go for it.
if people want to learn more about what this looks like, what we've been building at Manifest, part of our expertise in this area comes from building a system and capabilities that helps organizations with this exact problem across the defense industrial base and the US government. Feel free to reach out to us, visit the website. You can scan the QR code here. You can find me on LinkedIn. I'm always happy to chat more if this is a problem that people are facing and are looking either to chat through or looking to understand capabilities that can help mitigate that. And before I officially turn it back over to Hallie, just wanted to say thank you. Thanks for everybody for joining. And again, if there's a takeaway, it's we build and we buy lots of software and AI. We have to trust it. So what can we all do to make sure we trust the software and AI that our organizations build and buy?